All right, hello once again. This is Jeff Scott from Jeff Teaches Programming. And as you can see, I've been working with different programs using arrays. I had an array list, etc. And now I'm going to take it to another level. I'm going to talk about objects. Now I'm going to do this a little differently because in this lecture, I don't plan on showing any code or at least very little code, if any code. And I want to talk about what object-oriented programming is. So the first thing I'd like to do is to show you this. All right.
Hello, everyone.
Now let's see. Get this back. All right. This is a YouTube video. All right, I guess I'm just leave it right here. If you go to freecodecamp.com, which is a really nice site, they've got a lot of different stuff on it, and then you search for object-oriented programming, you're going to find this video. No, that's
important for software developers to understand
Good gravy. Let's start it over again. All right, object-oriented programming, period. All right, this is it, an intro to object-oriented programming and crash course. As you can see, it's about half an hour long, all right, 30 minutes. And it's good, yet you may find it confusing. And what I mean by that is it's a good video, it really and truly is. That said, all right, they talk a lot about chess pieces and playing chess in it. So if you're not into chess, etc., you might find it a little confusing, but it does talk about the 4 pillars of object-oriented programming. So again, freecodecamp.com. Let me pause for a moment so you don't have to hear my clock. All right, and as you'd imagine, you can go out, and I mean, if I go out to Google here, or not even to Google, if I just come into here and I type in, for example, object-oriented programming. I don't know how many hits I'm going to get, but there's going to be a lot, 948,000. And notice they break it up. And if I go to C#, there's going to be a lot of different things that we find. So now it says 949,000. Object-oriented programming with examples. All right. And C# corner, C# object programming, a complete guide. Here's Microsoft's, etc. But I decided to go a little bit different route here. And what I mean is I want to show you the 2 that I came up with. The first one is here, and it's from Stackify.com. So I'm going to bring this out here, and I'm just going to show it to you. And that's it. All right. Try to get it. There you go. Stackify.com/OOP-concepts-C#. We're going to go over that one in just a moment. I'm also going to go over another one here. And as you can see, it's a lot longer URL, but it's .NET-interviewprep.com, Mastering Object-Oriented Programming, OOP in C, a beginner's guide. All right. So let's just go through the first one. It really doesn't matter which one we cover first. There are going to be a lot of repetition between the 2, and you've already been told that. All right. So it says, if you want to become a C# programmer, terms like C# class and OOP must be part of your repertoire. You need to understand what they mean. Object-oriented programming is a paradigm, which means it's a shift in thought. All right. As it says, it revolves around objects communicating with each other as opposed to functions operating on data structures. All right. A class is a crucial concept in object-oriented programming languages, such as C#. So as they mention in here, in this particular article, they're going to discuss object-oriented programming. All right. So I'm not even going to start with this. So I'll hold off for just a second, and I'm going to give you a different kind of example. Not on screen, but I'm just going to talk you through this. So where I used to work at Rankin Technical College in Wentzville, Missouri, across the street from where I would tape my classes or have my classes in, there was a big tract of open land. Now, I have no idea how many acres were on it, but I'm going to pretend for this example, there were 100 acres of land. All right, in fact, I'm going to even do it like this. So again, I'm going to pretend, for lack of better words, there were 100 acres of land. And we're going to assume for just a second that a developer bought that land and decided on that 100 acres of land that they were going to put up 50 houses. Okay? And on those 50 houses, because they would have roads and other stuff in there as well. But in those 50 houses, they would have 5 house plans. All right? And they would have basically house 1, 2, 3, 4, 5. Then in the next row, house 1, 2, 3, 4, 5. Hopefully you get the idea. All right? Well, you wouldn't start, you wouldn't come in there after you bought the land. I don't think, at least. You wouldn't come in there and just start digging holes, and making, and doing stuff. You would have these house plans. All right. In other words, you'd have the equivalent of a blueprint for a house. All right. So a house plan, or in other words, a blueprint, that pretty much is what a class is. A class is a blueprint from which you can make objects. All right. Well, these houses are examples of objects. So in other words, as you can see right there, an object is an instance of a class. In fact, the idea of going in and creating objects from classes is called instantiation. All right? So to get started, if you understand what I'm saying here, you're on your way to understanding this. Now, this doesn't say why you should be using this, etc. All right? But it does explain what a class is, and it does explain what an object is. All right? So with that in mind, let's just start talking about this. Okay? So in this example here, they're defining an object as a cohesive unit of data and behavior associated with such data. What the hell does that mean? All right. Well, what it means, going back to our example here, is an object, and let's just move up. Let's put some white space in here. An object is an instance of a class, and an object typically contains both data and methods that operate on that data. And what a method is, it's a function in a class. You don't call the functions in a class functions, you refer to them as methods. All right? So as it says, an object typically represents a concept or an entity. The object's behavior represents what you can do with it. It says, how is programming with object different than the alternatives? Well, what we've been doing so far has been procedural programming. And as it says, in that paradigm, which is another way of thinking, there is a divide between data and behavior. You have data structures that carry the data around and don't do anything, and functions that operate on that. All right? And they give an example here. I don't know if it's a good example or not. I'm not even going to go through the example. All right? In fact, let's go through it. Okay. It says in a procedural language, if you had a string and you wanted to split it based on a comma, so if you wanted to split this into the three parts, 1, 2, 3 in one part, ASD in another part, and 345 in another part, you'd call something called split on the input, and you'd use the delimiter of being a comma. If you did it in object-oriented programming, notice the difference. Here you call split, but here you'd call input dot split. So it's the method or the function that can operate on the data. A class, as I mentioned previously, is a blueprint from which you can create objects. And as I also said, the whole process itself is referred to as instantiation. So they make a person object here. And they say the data for a person object will be their name and will be their age. Now, you'll notice in here that we've got underscores before name and before age. It's not mandatory that you do that. Plus, notice that both of those things are said they're private, so they're known only within the context of this person class, and that's the only place where you can change them. And they're read-only, meaning that once they're set, they cannot be changed. All right? Then you've got this, and you'll notice this function here, or method I should say, is the same name as the class. And that's usually referred to as a constructor. So we're about to construct an object of this class. And it says we're going to pass into it a name and an age. The name we pass into it will be put into the person's name. The age that we pass into it will be put into the person's age. And then we've got another method in here called introduce. That once you've set that, for instance, if I put in here Jeff for the name and 69 for the age, my name is Jeff and I'm 69 years old. So as it says, in this class, we're defining both the data and the behavior together. So how do we create objects? Well, here's our first example here where we are creating or instantiating objects. We create a new person. The name will be John Doe. The age will be 25. We create another person, and their name is Mariah Silva, and their age is 32. So this will say, my name is John Doe, and I'm 25 years old. My name is Maria Silva, and I'm 32 years old. When you call this, it's going to print out this. And when you call this, it's going to print out this. And that's all they're trying to show you. You can, when you're working with C#, rather than saying person P and person P#, you can say var. And when you use var, what happens is this system here is going to basically determine, oh, you mean a person. Okay? And there's even another way that you can do this. You can use the word new. Now, I'd recommend looking at these three and using the one that makes the most sense to you. I mean, I was kind of taught mostly this way here. So I probably do it that way most of the time. All right? Okay. They mentioned that in this class that we made, we've got a person's name and a person's age. Okay? And we made them private, which means that other objects can't access these values. It says, what if we wanted to let other objects know these values? Would it be possible to define them as public? And the answer is yes, but you should Methods should be public. Data should be private. All right? I was asked once, give me a real simple example, simple definition of object-oriented programming, also known as OOP. And I said, in a nutshell, it's public methods operating on private data. Now, that said, can you have private methods in OOP? The answer is yes. Can you have public data in OOP? The answer is yes, but it's rarely, if ever, recommended that you do. Why? Because as it says, it would break what's called encapsulation. Don't worry, we're going to talk about what encapsulation is in just a moment. All right. So notice what they're saying here. This public person, just like we showed before, we've got this read-only, just like we showed before. This is the same as what we showed before. This is the same as what we showed before. But now look what we're doing. We're using what are called getters. So imagine, this is the example that I've always given to students. It's the first day of class. And the first student comes into class. Nobody else is even there yet. And I say, hi, my name's Jeff. What's your name? It's a young lady, and she says, my name is Kathy. Okay, fine. So a couple minutes later, another student comes in, and I say, hi, my name's Jeff, and she says, hi, my name's Kathy. Well, that could be kind of confusing. So when class starts, I say, you know what? I'm going to call you Kathy 1, and I'm going to call you Kathy 2. What I've done there is not used a getter. I've used what's called a setter. I have changed so that instead of calling her Kathy, I call one Kathy 1, and instead of calling the other one Kathy, I call her Kathy 2. So that's a setter that sets a value. When I asked them their name and they told me, that was a getter. They returned a value. So getters return values. Setters allow you to set values. All right? So we talked about methods already and mentioned that a method, as it says, they're functions defined inside of classes. All right? It says there's no mystery to creating a class if you're using Visual Studio. Just right mouse click, then go to add and click add class. We'll talk about that in just a bit. Now, let's talk about what are referred to as the 4 pillars, the 4, whatever you want to call them, of object-oriented programming. And I'm at 18 minutes, so I should be able to do this in about 10 minutes or so. The first one is abstraction. And as it says, it hides unnecessary details from reference objects and names. And one of the things to understand with abstraction is the idea of an interface versus an implementation. All right? Now, this is the example I typically use for this. So let's say I come in here and I bring up my calculator. And I want to know the square root of 347. So I type in 347 and I hit the square root key. I don't even know what it is on here. We even have a square root key on here. Okay, there you go. Now, do I know how that worked internally? When I hit that button, do I know how it converted 347 to 18.627, etc.? No. What I knew was that when I did this, I had to type this in, and I had to hit this button. That's my interface to this. That's what this calculator let me see. The way that turned that 347 into 18 point something is the implementation. So with abstraction, you want to only show what the user needs to see. That's your interface. But the implementation, as far as how it's done, all right, you don't want to show that. So instead of showing how an object it works, it focuses on what the object does. All right, we do a lot of abstraction in our lives. In fact, one of the things they talk about in that video, that free code camp video that I mentioned, is they talk about driving a car. And they say people know that what the brake pedal is and what the gas pedal is, and that you need gas for most cars unless it's an electric car. I get it. But most people don't understand. I don't. For example, if my car is in my driveway and I start it up and I put it in reverse, I don't know what's happening internally in the car. That's been abstracted from me. All right. Then we have encapsulation. As it says, a class encapsulates the methods, properties, and attributes. Okay? As it says there, this is very, very tight with the concept of abstraction. It says encapsulation is achieved by creating classes which display public methods and properties. Typically, the properties are not going to be public. Properties are the data. All right, so that's abstraction and encapsulation. Let's skip for a second polymorphism and go down to inheritance. All right, now again, examples I've always given. Typically, if you've got a guy who's got a big nose and he marries a woman who's got a big nose and they have a baby, quite often the baby will have a big nose. That's inheritance. They inherit it from the parent. It's not like the baby has got two choices, basically. They can live with what they have or they can get plastic surgery. It's not like they can take the nose off and put on one they'd like. But you can kind of do that with inheritance in a programming language. All right? Inheritance is known as an is-a type of relationship. For instance, if you make a class called dog, a golden retriever is a type of dog. If you make a class called car, all right, a Toyota Camry is a type of car. All right. So you can take a class and have it basically inherit from another class. All right. Finally, the last one here is polymorphism. And as it says, there's two types. There's dynamic polymorphism, which happens at runtime, and there's static polymorphism that happens at compile time. All right? And for now, let's just concentrate on the first one, on runtime or dynamic polymorphism. If I came through and let's say, I'm going to try to make this simple, that I came in here and I created a class called dog. Now, let's make it even simpler. A class called animal. And then I created another class called dog. And I created another one called cat. And I created another one called bird. I don't know. Let's just keep it at 3. That's fine. All right. And let's say that in this animal class, I created in here a method called speak. All right. And let's say that in here, I created another method called speak. And in here, I created another method called speak. And in here, I created another method called speak. Well, if I was working with a dog, so if I came in here and like I said before, let's say I had a golden retriever, which is a type of dog. All right. So let's say I create a golden retriever that I call, I don't know, Lucky. And I say lucky.speak. It's going to say bow, wow, arf, arf, woof, or whatever. But if I come in here with a cat and I've got a calico cat, all right, and I tell that, let's say that I create a cat and I call it Fluffy.speak. Well, that's not going to say bark or roof or whatever. All right, that is going to say what? it's going to say meow or purr or whatever. Then if I create a bird, and let's say that I create a parrot, and we'll say the parrot is Polly. So Polly.speak, that's going to say Brock or whatever a bird would say. So the idea when you look at these, let me straighten these out a little bit. Is the system knows based on the type of class you're working with to call either a dog speak, a cat speak, or a bird speak. And it does that, and it does it at runtime based on the type of class you're working with. That's dynamic polymorphism. All right. On the other hand, you can have static polymorphism. Now, that talks about two different things in here, method overloading and method overriding. And believe it or not, I have already shown you one of these. All right. What do I mean? Well, let's paste that in. I've already shown you method overriding. There is a speak method here, and I've both overridden it and I've overloaded it. So when you overload something, as it says, you define several methods at the same time. When you override, you are saying rather than using the one that was defined here, use the one defined for a dog or the one defined for a cat or the one defined for a bird. All right. Now, this is going a little longer than I thought it would, taking a little longer than I thought it would. All right. So what's a common practice for naming classes? Typically, they start with a capital letter. It's best practice to have the class name match the file name. So if you've got a class called invoice repository, it should be in a file called inventory repository.cs. Variable value types and reference types. A value type stores an actual value. A reference type, for lack of better words, shows kind of like a pointer to a value. All right. The default accessor here is what's called internal. Don't worry about it for now. We're going to talk about it in our next video. And I showed you what a constructor is. All right. And there's more to constructors than I've shown you. So I'm going to stop right now with this one. And in my next one, I'm going to go to this one, Mastering Object-Oriented Programming in C#, a beginner's guide. There'll be a lot of repetition, but I think that's a good thing. I'll be back with that shortly.